All right, let's go ahead and get started. Thank you, everybody, for joining us today. We are on a webinar today to talk about rethink storage performance. Again, appreciate you joining us. I do want to do just a couple of housekeeping items before we begin with the presentation. If you have any questions during any part of this presentation, you can ask them via the chat panel, and one of our panelists will get to a response as soon as we can. Again, thank you for joining us. My name is Leslie Spinks. I am the Business Development Director for Freeit. We also have as a panelist today T. Glasgow, who is a Systems Engineer for PernixData, and Jack Bailey, who is also a Systems Engineer for Zerto. Today, like I said, we're going to talk about rethink storage performance. And we have two fantastic products to talk about, PernixData and Zerto, both with their own unique feature set and their own position within the data center. First, I want to tell you a little bit about Freeit, and I will go ahead and get started. Again, if you have any questions, please feel free to pop those over in the chat. Freeit is a value-added reseller, systems integrator, who is located in Austin, Texas. We cover the entire state of Texas as well as the United States. We really focus on newer technologies that fit in the data storage and virtualization space, similar to PernixData and Zerto. And our mantra really is making it simple. And that for us means that we look at products and we bring products like PernixData and Zerto to our customers that are meeting these criteria that you see here in front of you. So we really have embraced the changes in the industry where we find these newer up-and-coming technologies that are, changing the industry really, and we're finding that they fit into, these categories here, and that they really are all similar with these respects here. So what does making it simple mean for you, right? So simple install, what does that mean, right? It's not costly, it's not lengthy, right? Those are the typical kinds of engagements that you see. Our typical installs take less than 1 day, not weeks, like some of the ones you might be used to with some of the legacy storage vendors. And our quotes have a single line item for all of our installation services. So that definitely includes PernixData and Zerto, the two products we're talking about specifically today. But any of the storage vendors that you can think of, that you might be using, any of the point solutions, we like to call them, or any of the backup and recovery solutions, we typically can install those in less than a day, and it's a single line item for an install on the quote. We also provide simple management, right? So all of these products that we're going to talk about, or any of the products that we would solution for you, the customer, they're really simple to manage. Not only are they simple to install, simple to migrate and put into your environment, but they're really easy to manage once they're in there, right? There's no storage PhD required. I'm sure you guys are used to the certification process that you have to go through for many of those storage platforms or networking platforms. Most, if not all, of the solutions that we represent don't require any lengthy certification to use. And most of them are allowing you to manage that platform via web interface or some kind of vCenter or existing integration into your infrastructure. So they make it very simple to manage, very simple to integrate with something that you're already doing. They're lower cost, right? That doesn't necessarily mean cheap. It just means that they're lower cost. And most of the solutions, if not all of them, use a unique software architecture to accomplish most of that, right, to reduce that cost. It also helps you reduce the physical and virtual footprints in your data center. And what we see on average is about a 50% lower cost per terabyte than some of the legacy storage vendors that you might be used to. And in addition to that, what you'll see is that you get better performance with these products than you might with some of their competitors, which also adds to a lower total cost of ownership. We also really focus on purpose-built technologies. So our expertise is in a lot of the flash, the hybrid, the converged platforms that really fit into, high demand, hyper virtualized type environments. And, they're simple design, right? So it's not a complex architecture that we build out for you and then, it takes weeks, right, coming back to the simple install. But these are really purpose-built to solve specific needs within your data center. So they're really, really easy to design within your existing infrastructure or create a completely new one out of these purpose-built technologies. And again, they're very simple to integrate with each other and with existing technologies that you already use. A lot of them that we feature are also storage agnostic, and I can tell you two of the products we're looking at today are storage agnostic. So that also helps to reduce the hardware cost, right? You can use a lot of your existing infrastructure, or you can buy, commodity hardware to operate on. And again, that, allows you to reduce cost. If you can use existing infrastructure, it reduces that overhead time, et cetera, et cetera. So it also allows you to do blended environments. So if you want to do a, primary site that maybe had a little better infrastructure than your backup, right, then you can do that, and it also works seamlessly that way as well. And the last thing I'll mention is, we represent over 30 industry-leading technology partners. You're getting a glimpse at two of the best here today. But we represent a lot of manufacturers on the, all-flash side, hybrid, converged, whether it's VM replication, VDI. The list kind of goes on. And, I could bore you to death with all of the solution sets that we do focus on, but, here's just a few of them. Again, a lot of these products really fit a specific need. So if you're looking to accelerate applications, you're looking to set up some type of, backup and recovery environment, whatever the case may be, we really do focus on these newer, we call them point solutions, that are specifically designed and provide you with a unique option in that particular area. Here are just a few of our customers wanted to highlight. Again, we really span the full spectrum of customer set. We are headquartered in Texas, but, again, we do have customers all over the U.S., and we really have provided a lot of these solutions like PernixData and Zerto to, companies like Accenture, Texas A&M, University of Texas, U.S. Army, so on and so forth. So very unique. Again, we design custom solutions. We are a value-added reseller systems integrator for these types of technologies. And if you have any questions, here's my contact information. Feel free to reach out to me directly. You will be getting some correspondence from us after the presentation, and we would appreciate to talk to you one-on-one a little bit more about your current environment and some of these great new products. So again, I thank you for your time. Thank you for joining us. I'm now going to turn it over to T. Glasgow, and he is going to talk to you a little bit about Pernix and then give you a demo. And there you go, T.
Thanks, Leslie. Hey folks, my name is T. Glasgow, and I am a systems engineer with PernixData. I'm going to talk to you for a few minutes, give you an overview of what PernixData is all about, what FTP, our software product, is all about, and kind of walk you through at a high level who we are, where we've been, and where we're going. And then I have a few minutes to roll through a live demo showing you how to interact with PernixData FTP. So PernixData was founded a few years ago by Poojan Kumar and Satyam Bengani. Poojan was with Oracle, was one of the co-founders of the Exadata platform, head of the VMware data storage group. And Satyam Bengani is our CTO. He was also a VMware storage CTO, and he's one of the original creators of the VMFS, Virtual Machine File System. Wrote the original spec for vStorage API for array integration and also for vVols. So our development staff has come from multiple different tier 1 companies like VMware, NetApp, EMC, Data Domain, and the like. And we've been in business now for going on 3 years with some of the Silicon Valley's top tier venture capital firms backing us, and have raised quite a bit of money to date. We've got some very some industry luminaries as our board of directors, like John Thompson, the CEO or the chairman of Microsoft's board of directors, former CEO of Veritas, Mark Leslie, and Mark Benoff, the CEO of Salesforce.com. So we've got a pretty strong leadership team behind us. The problem we're trying to solve is really one of decoupling storage performance from storage capacity. Traditional storage systems are in a virtualized environment struggling to keep up with the demands of the VMware virtual machines and the applications running inside of them. So we're seeing, again, more of a I/O blender effect, the I/O being more random with the increase in consolidation ratios of VMs to hypervisor hosts. We're also seeing a limit in the amount of bandwidth available from storage fabrics. And finally, we're seeing storage controllers also limited in their ability, their resource capabilities to be able to keep up as the capacity grows behind them. We've anecdotally have found that VMware's support is receiving more and more calls. Upwards of 70% of the issues related to performance are focused more on storage. So the opportunity that Poojan and Satyam saw is, why are people buying storage array capacity in order to mitigate or reduce storage performance bottlenecks? So the solution, take the existing infrastructure from the previous slide where you have servers, you have your network fabric, you have your storage arrays, and what we see is an opportunity to take, for example, everyone's used to hearing about flash today. There's a lot of noise in the storage space relative to flash. Where do we put flash? Do you put it on a traditional array, an AFA, a hybrid array, or where's the right place? We believe that if you're going to interrupt a CPU to complete an I/O, which could be a read or a write operation, it would be much, much better to lower the latency curve and increase throughput, increase IOPS, and ultimately increase usability of virtualized applications by keeping those responses to these IOs closer to the CPU that's actually doing the work. So what we've suggested is take flash and place it into the ESX hosts. And that way we can wrap that ESX server using PCI flash, SATA, SAS-based flash, or even excess available RAM the servers already have. You allow FTP to use those acceleration resources in order to keep the I/O closer to the CPU. Basically, what that translates to is lower latency. So you'll see virtual machines in the top there running on these hosts. They're being scheduled to run on real CPUs. They're being scheduled to use real pages of memory. They're also using data that's stored in a back-end array. So by using things like flash and RAM along with FTP in the server, which is installed as a vSphere install bundle and patches the VM kernel, FTP is now in the data path and able to take read requests or write requests from the virtual machines, place them on these acceleration resources within the server, synchronously acknowledge back to the VM much quicker, therefore reducing the round-trip latency, and then still provide our customers with the benefit of the back-end storage, the bulk storage capacity they've come to rely on for shared persistent data storage with data management features. So it doesn't really matter if the customer uses Fiber Channel, FCOE, iSCSI, NFS, so block or file protocols. We support all these protocols, and we're basically allowing the virtual machines now to be able to hit a lower performance curve than they've ever been able to prior at a much, much more scalable storage footprint. The performance now for storage is scaled up into the server and scales out linearly, and also allows you to keep your hardware costs down to a much different, much more manageable level. So just a couple of examples here of some of the customers. Everyone has one of these slides that sort of shows that you're not first to adopt the technology. We've had some great successes in various different segments, from SMB all the way to enterprise, education, government, different verticals relative to telco, healthcare, and the like. A couple of examples, Disney, Dykema. We've got several examples of customers that the use case for example, SQL, virtualizing SQL is generally one of the last bastions of virtualizing any application, generally because of the I/O demands that it puts on the hardware infrastructure at scale. Perfect example, Dykema had 43 SQL licenses. When they began the pilot with FTP, they were seeing a significant increase in throughput and a much lower latency, to the point where they were able to reduce their SQL licensing down from 43 to about 8 servers, saving them about $1 million a year in SQL licensing. So these are just a few examples. The use cases of FTP tend to span the usual business spectrum. We've got customers using us for SQL databases, Oracle databases, SharePoint, Active Directory Exchange, the usual Microsoft business apps, as well as virtual desktop infrastructure. We're a great resource to be able to mitigate all the performance demands put on a hardware infrastructure by virtual desktops, whether they're booting up, logging on, logging off, application startups, recompose operations, and the like. I'm going to show you a couple of quick examples here of a couple of our customers, and these are just screenshots from the FTP tool here that show what some of the performance gains look like. For example, for Starbucks, they were able to reduce their demand and dependency on the storage rate to provide a higher level of IOs per second, and gain using FTP, the throughput potential increased 10x to the point where they were able to actually execute far more IOs using the server-side flash. And then looking at the example below for Bank of the West, you can see the chart follows their latency there for read latency milliseconds along, pretty spiky, 10 to 15 millisecond range. And when they enabled FTP and allowed FTP to be able to accelerate these reads, what ended up happening is the latency, the round-trip latency from the VM to be able to read data back from the flash decreased to an 8x value. So these are just a couple of examples. The tool provides a significant level of visibility into the performance of latency, IOPS, and throughput. And we also have some charts specific to our software. So what I'd like to do is just take a couple of minutes and walk through the interface and kind of talk at a high level of what you would be dealing with. I'll talk about the installation. I'll also demonstrate creating an FTP cluster and selecting workloads to accelerate. And then finally, I'll show you what the performance management tools look like, the resource management and performance metrics look like as we gather them. So let me switch over. I'm going to switch over to my vSphere client. I'm connected in using the thick client. We also support the web client. I'm just going to demo today using the C# client. So what I've got here is I've connected into a vCenter server. I've highlighted one of the clusters in the inventory, central cluster. There's a couple of ESX hosts in that cluster, ESX 1 and 2, and there's a virtual machine running on each host. So this is kind of the minimum sort of hardware to demonstrate the functionality of FTP. So the installation part's very simple. It's basically 3 parts. First part being put each host in maintenance mode for the cluster and install our bid, a vSphere install bundle. Just run a simple command. The installation completes, you take the host out of maintenance mode, and then you move to the next host. The time involved is basically the time waiting to live migrate VMs off of each host as the maintenance mode operation initiates. So once that process is completed, you move on to the second step, and that's deploying the FTP management server. So we tell our customers just build a Windows VM with a SQL database, and the purpose of that VM, it will become the FTP management server. So through the installation of that management server software, you'll connect it to your vCenter server, and now you have the ability to go to this interface and interact with these ESX hosts and virtual machines and create the clusters and the acceleration tier to be able to accelerate the workloads. And lastly, we have a plug-in to the web client. Once you've installed the management server and made the connection to vCenter, you can just log out of the web client, log back in, and you'll see that plug-in and underneath the vCenter in the inventory. Or with the C# client, like any other management plug-in, you would just download and install the FTP plug-in for the vSphere client, And once you reconnect to vCenter, select your cluster, you'll see the various VMware-related tabs. You'll also now see a PernixData tab. So this is our user interface that allows you to communicate and manage these clusters. So at a high level, the basic steps after the installation are to create an FTP cluster. So I'm just going to go over here and quickly demonstrate that. I'll just give it a name, an optional description, and at that point the cluster exists. So essentially wherever I've clicked over here affects where that cluster will then straddle. So this is the FTP cluster built on top of the ESX cluster. So underneath here under configure, I have a couple of different options we can go through. Second step of the 3 is to add the resources. Got the resource type filter to show both flash and RAM. And I've got ESX1 with its devices that are available and ESX2 with the devices it has available. Again, you'll notice this is based upon the ESX cluster I've selected in the inventory. So for the sake of example, I can select RAM from each host. Before I can click OK, with RAM I have to allocate. So we show you with RAM, for example, there's a total capacity of RAM installed physically in the server. The VM kernel has a portion of that reserved to be used by, for example, the VM kernel itself, as well as the RAM used by the virtual machines. Then there's also usually excess RAM, and we can take advantage of that. We can allow you to use that excess RAM to be able to serve as the acceleration resource for the I/O generated from the virtual machines. The minimums are 4 gigabytes, and the maximum is 1 terabyte per host. We support what VMware supports. So if you have 32 node clusters and you have a terabyte of excess and available RAM, then you could create a 32 terabyte RAM-based FTP cluster. Once the allocation of the RAM is complete, I'm just going to leave it at 4 gigs out of what's available. I'll click OK. So second step of 3 steps is complete. The last step is determining which virtual machines that you want to accelerate. And there's a couple of different ways to do this. We can add the VMs individually or in groups, and we can apply a write policy to the virtual machine. The write policies that we use are write-through caching and write-back caching. And somewhat similar to the familiarity you may have with the storage arrays features of write-through and write-back caching, we're implementing the same kind of concept, only we're doing it at the server layer. And we're using each of the ESX hosts in the clusters to back each other up with fault-tolerant writes if you choose write-back as the option. Write-through just reads from the storage array, copies data into the acceleration tier, and serves it back to the VM simultaneously. Rereads occur from the acceleration tier. So your dependency of reading from the array and therefore incurring the latency of reads from the array has been eliminated. Writing is 100% hits on the acceleration tier, and that's the write-back caching feature. So we can allow you to write to the flash and receive synchronous acknowledgments extraordinarily fast compared to the capabilities of the data store. The other way to add virtual machines to the clusters by choosing Add Data Stores. The one I use for my demo, where my 2 virtual machines are located, is this LUN. It might be an NFS LUN. The process is effectively the same for block or file. I have 2 VMs in this data store, and I can, again, apply a write policy to that data store. The added benefit is any virtual machine that's deployed to this data store or created brand new within this data store in the future will inherit the write policy that I apply at the data store level. By the way, that can be overridden at the virtual machine level, so there's a great deal of flexibility in how you accelerate your VMs. Again, right through, I can select that. If I only intend to accelerate read I/O, and I can click OK and I'm finished. If I choose write back, I have to make one more decision. Write back comes in 3 different configurations. We always write locally, wherever the VM is local to either of the hosts. So that's the first configuration, would be write back plus 0 peers. Next 2 configurations we allow are write back plus 1 or write back plus 2 network peers. And so what we're doing is we're allowing FTP to copy each write from the local host across the network to the other peer host, write it to its acceleration resource. Once both hosts in that configuration have the write committed, then the sync acknowledgement is provided to the VM. It can make progress, and then FTP's job is to asynchronously destage that write from the acceleration resource out to the storage array to keep it persistent and shared. So this is a differentiator of what makes us a true enterprise solution. So the process to set up an FTP server environment, pretty straightforward. Doesn't take very long to set it up. The process to actually create clusters and actually accelerate your workloads is a fairly straightforward process. The next phase really is, what does it all look like after you've set these clusters up and you're running them in production? So I've got a different vSphere host here where I'm running a cluster called Lab Cluster 1, and we've got 2 hosts in it. And out of those 2 hosts, I've carved out 3 different clusters, one called Gold, made up of SATA SSDs, one called Platinum, made up of PCIe SSDs, and one called DFTM, or Distributed Fault Tolerant Memory, which is using the excess RAM from these 2 hosts. So I'm just going to show you what Platinum looks like, and we'll kind of take a look at the performance metrics here. We're essentially just these 3 buttons in the UI, and you can see kind of the overall health of this particular cluster down below. You can see the hosts, the actual devices that are being used by each host locally as the acceleration resource, and then of course out of the total eligible VMs, how many are powered on and actively reading and writing from these acceleration resources. In the lower right, we have kind of our first proof point of what the FTP software is doing in the environment. So historically, since the date of creation, we began collecting these performance measurements. These are just time measurements, but also operational measurements of what actually has occurred. So IO save from data store is showing you that there's a little over 5 billion reads that have been served from these flash devices. And then we can see the writes accelerated. Almost a little over 3.5 billion write IOs have been written to flash first. And a result of reading and writing to the flash devices initially, then the IOs are not having to cross the HBAs to the server, being queued up, crossing the fabric, and having to contact the storage array for initial access and response. So each of these operations, depending on their size, will translate to a savings. And what that savings equates to in this particular example is nearly 73.5 terabytes of bandwidth beyond the servers or array controller resources that did not get utilized initially to serve reads and writes. So this puts a far less of a demand on your storage arrays. If there are physical servers in your environment, there's extra resources essentially that have been made available to those servers. So another thing that's interesting about FTP is we have this feature called adaptive network compression. FTP network savings will report its benefit. So as the virtual machines that run on these hosts that are in a write-back +1 or write-back +2 configuration, as they read and write to these devices, and as the writes are replicated across the network to the other host, the writes on when the writes are 16 kilobytes or larger, FTP will automatically compress those writes as long as the network between the hosts is 1 gigabit per second. And as it compresses, it sends the compressed write across the network to be written to the peer. Well, the side benefit there is we're reducing the amount of network bandwidth required to do the write peering. And this is only available, FTP enables this by default on 1 gigabit networks. It doesn't turn the feature on 10 gigabit networks because there's no appreciable benefit. There's plenty of bandwidth. So the next thing we'll show is the usage. And I'll just pick one of the VMs in the list, and I've sorted on local acceleration usage from top down. You can see the local usage is varied depending on the workload. There's several different workloads in here. Some are powered on, some are powered off. But at the very top, looking at the SharePoint VM on ESX5, its local usage of the RAM or the flash, depending upon which is your acceleration resource, totals out to about 823 gig. Down below, the primary host, ESX5, is this PCI device, and that workload's about 63% of the total capacity. So what we're seeing here is the FTP software telling you exactly how much read and write I/O is active for each virtual machine dependent upon, of course, where they run locally too. So this is a tool that you can use moving forward, that you can actually size the resources that you're using within the ESX hosts, whether they be RAM or flash, appropriate to the workloads that you're actually going to run in these clusters. So it also gives an indication that every workload in your data center, maybe a tier 1, tier 2, tier 3 type breakdown, every one of those don't have to be wedged into the same FTP cluster. You can build multiple clusters, put the tier 1 workloads in RAM, the tier 2 in PCIe, and the tier 3 in SAS or SATA, for example. Okay, so kind of moving on from there, I'm going to show you the performance charts. And these views are relative to obviously the cluster that you're viewing, so I'm just staying on Platinum. There's a time range breakdown from the past 10 minutes to the past month, and you can even create custom time range breakdowns. Okay, the storage, the breakdown of the actual legend over here, the storage breakdown is based on the type. In other words, the time latency measurement from the VM kernel to read and write to the local acceleration resource, whether that's RAM or flash, the required, the latency, the IOPS or the throughput for network acceleration, in other words, the write-back replication between the ESX hosts. And then, of course, there's a time measurement from the VM kernel's memory space to the actual ones in the storage array. As a side benefit, you'll see with the virtual machines able to read and write to flash or RAM, what their actual latency measurement is. And all of these four are nicely overlaid on these performance graphs. You can also change the breakdown to show the read to write ratio relative to latency, IOs per second, or throughput in kilobytes per second. And then you can create custom breakdowns that actually overlay these storage types as well as reads to writes that actually break down a very granular level to show where the latencies are very specifically, or the IOPS or throughput. And so what you're seeing here, for example, I'm going to kind of zero in on this spike for this. This is a cluster view, summary view showing the latency effectively for the 17 virtual machines, which we can drill down and show in specific VMs. You're seeing a spike here that shows, for example, the data store latency at this moment in time was about 198.56 milliseconds. So the latency of time to read and write to the local tier or the flash was about 0.29 milliseconds. The write replication would have been 1.12 milliseconds. Now, local acceleration and network acceleration don't perfectly add up to an identical number to the VM observed because the metrics are normalized. What you're seeing is, since the virtual machine is able to read and write to flash, that its observed latency, while the array was nearly 200 milliseconds, the VM was able to show a latency or provide an experience to the users interacting with the application of about 1.4 milliseconds. So a significant drop in the storage performance, or to say it a different way, a significant boost to the I/O performance of the virtual machine. Again, we can look at these metrics over time. You can see a great deal of granularity from today backwards. What has the performance resultant been? This is a lab environment. It doesn't perfectly reflect what life looks like for production applications, but every environment is different, but it does give you some idea of the visibility that we provide with our software as you're using FTP in your data center. Of course, we can show the IOs per second, the throughput. We have a couple of graphs that are specific to our world. We can show the hit rate and the eviction rate relative to the way the VMs are using the acceleration resource. So the ideal scenario would be zero evictions and 100% hits. And we only count the reads in this chart. We don't skew this number with the writes, since we always write to flash. So this is how we're showing you how well your workloads are reading from the flash device as an aggregate. And then we can drill down on an individual VM even, show the same thing for SharePoint, latency, IOPS, throughput. We can show its hit rate of flash. It's pretty close to 100%, dropped off. Could be the VM powered off, could be a big burst of writes, could be the data set didn't have a very focused locality, so the virtual machine had to go back to the array to read in new data. Therefore, FTP copied that data into the flash, so that the virtual machine could in turn reread that same data from flash in the future. Then we also have a graph for write-back destaging. And this shows the time in seconds that it would take to destage asynchronously a certain number of bytes of data from the server out to the actual SAN, or the storage array. So here we're seeing a relatively low time measurement to move 1.17 megabytes from the server to the array. Okay, so that's kind of the big picture on FTP. I'm going to check out the the Q&A window and see if there are any questions that have popped up for me. Okay, let's see. Looks like I've got what happens when a host in an FTP cluster fails. One of the first questions I got here. The reason that we do the write-back replication is because we would anticipate something like that actually happening. So back to my conversation about write-back plus 1 or write-back plus 2 network peers. What happens is, for example, virtual machines running, everything's normal, issuing writes, the replication to the other peers is happening, and all of a sudden the server crashes after the sync acknowledgement. What would happen is VMware HA would take over and do its job, for example. It'll move all the powered on VMs to a surviving node in the cluster. The virtual machines then would wait for FTP to do its job, which would be to scan the logs of the writes that have been synchronously replicated across to the other surviving node. It would account for any writes that didn't get destaged to the array, and it would make sure that those writes were then destaged. It would allow that virtual machine then to start back up like normal. So our primary, our goal is to accelerate I/O, but our sort of rule of operation, our priority of operation is to not lose data and to always account for data in flight. Second question was, what tool can you use to determine how much flash memory will be needed for your own specific environment? And so that's a very common question. The tool in and of itself under usage shows, again, the local active working set for each workload individually. My recommendation to folks has always been, take for example, anecdotal information. We've got lots of customers that we built our business on that started out using SATA SSDs, and we'd recommend usually in the 200 to 400 gigabyte range would be adequate to run the pilot and move forward. And the thing to remember about FTP is, yes, it'll tell you how much flash is necessary for each workload. The other thing too, FTP is very flexible. It allows you to really bend your needs, bend FTP around your needs versus bend your data center and your data around it. So for example, if you start out with an SSD that's 200 gigabytes and you slightly have undersized, FTP will allow you to, on the fly, scale and add an additional flash resource to your host and therefore add it to your cluster, your FTP cluster, without having any disruption to your normal VM operations. We really allow you to mix flash of any type, so different manufacturers, different capacities, even mixing SLC, MLC. There's obviously performance differentials between the two, but the point being is we support what VMware supports from a hardware perspective, and we're very flexible in terms of allowing you to scale your FTP cluster capacity based on need moving forward. And then the same would be true with RAM. The key with RAM is you can start out with a certain number of gigabytes rather, and you can, on the fly, increase or decrease the amount of RAM depending on need. The next question, when should I accelerate using flash and when is it better to use RAM? And that's really more of a dependency on a lot of things relative to how have you designed your power. RAM is still volatile. So if you have server reboots, the RAM will still clear. So that's part of the reason we've proved out our write-back functionality with fault-tolerant writes so that we could apply it using things like RAM. The performance profile of every application is different. The demand or need for every environment is different. Having multiple power sources and then replicating between servers and different PDUs is obviously key there. But the RAM is extraordinarily fast. It does not have the same limitations that even flash has. RAM doesn't care about I/O that is sequential or random, bursty. RAM doesn't have those same limitations, and it is extraordinarily fast. If you have tier 1 type workloads, non-persistent virtual desktops, for example, where even if you did suffer a reboot and all the VMs had to be rebuilt, they're powered on in a non-persistent state. If you're a software development shop and you have your data stored on your storage array, you may run software compile jobs, and that could take overnight. You could run those software compile jobs on an FTP cluster built on top of RAM. It would speed the process up significantly, and even if there were a reboot, the software compile job could easily be restarted because the data is, again, stored on the storage array. Another question was asked was, how is this different than vSphere 5.5 Virtual Flash? So to be specific, VMware came out with vSphere 5.5, and they released a feature called vFlash Read Cache, VFRC. The VFRC by name, vFlash Read Cache, only accelerates reads. There's a little bit more to the setup than what I've showed you. We accelerate both reads and writes. Most applications do some degree of writing. To be honest, most of them are closer to 50-50, depends. But there are writes that most folks do want to accelerate, and we're the only, we're the company that can do write-back caching in the servers for VMware environments. VMware has another product that people often confuse us with called vSAN, the virtual SAN. It's their goal there is to design software and create local data stores such that it is a virtual SAN made up of multiple ESX hosts. And there's requirements that they've set forth. In other words, you need a flash device and a certain number of bulk capacity disk devices, all loaded physically within the server in order to satisfy the configuration requirements in vSAN. We're not a primary storage play. We're simply accelerating what you have as far as your existing primary storage. If you have a strategy that's moving more towards direct attached storage or hyper-converged type storage, vSAN might make sense. If you have an existing storage array footprint that you're trying to get better performance out of without having to go back to the well to get another huge check to enhance the performance of that array, then FTP is the play. So we still depend upon primary storage. If I've missed any questions, I think I've covered everything in my chat window here. And with that, if there's nothing else, I'm going to pass this over to Jack. Let him talk to you about Zerto.
Excellent. Thanks for that, T. So I hope everyone's enjoying their pizza. I'm definitely jealous of everyone getting to enjoy that. We're going to walk through a few slides today to talk a little bit about what Zerto is, and then much like T did, we're going to hop into a lab environment and show you guys a little bit of the way Zerto functions and really how it simplifies DR to make recovery points in terms of seconds, failovers in terms of minutes, all with a ton of scale and a ton of simplicity. All right. So many of you know that business continuity is really becoming a requirement. Your end users, your customers may expect it, may demand it, but in reality, in the past, disaster recovery was complex. Oftentimes, you had requirement to have matching hardware, cumbersome agents, maybe long deployment timelines, and certainly there's a lack of flexibility and awareness of your virtual environment. Zerto works very differently. Zerto is the very first hypervisor-based replication solution. And as we go through our demonstration today, we'll show how this really benefits you. So simply put, Zerto provides enterprise-class virtual replication and business continuity DR solutions for data center in the cloud. So we'll break that down real fast. Enterprise class DOS means replication in terms of seconds, recovery in terms of minutes, but most importantly, it does all this without impacting the performance of your production VMs or requiring downtime or even maintenance to install and use. Super simple to deploy and very, very powerful tool after that. Virtual replication means the Zerto is virtually aware. This integrates into your hypervisor, some of the tools, as I'll show you in the demo, and scales without the need of adding or managing hardware, which is key. So just to look at some of our customers, we have a pretty large ecosystem here, and across the board, there's a number of different verticals. Everything from small, medium business up to Fortune 500 companies can leverage us. Whether you have hundreds of VMs or just a handful of Tier 1, Tier 2 applications, Zerto is a very powerful tool for protection, for protecting those machines. Just a real quick case study. You see one of our customers, Woodforest National Bank, has a very common problem that we see with a lot of customers. They had a very complex process. They were leveraging array-based replication, and it was very inefficient of IT assets. One, from a management and maintenance perspective, it was complex. And also, it was leveraging a lot more of their storage and a lot more of their bandwidth to make replication occur than they really wanted to have happen. So for them, Zerto really reduced complexity, simplified their environment, and certainly their architecture, and they had huge results with us. And this is a very common occurrence across the board with customers. They were able to reduce the amount of LUNs they leveraged. Zerto doesn't care where the data is at, which data store it's at. It's able to replicate without you having to sort machines or applications into data stores. It certainly reduced the amount of bandwidth requirements they had. We'll touch on this in a moment, but Zerto has built-in WAN compression capabilities and is incredibly effective at replication across the WAN. And it certainly reduced the overall storage of the target site by only replicating what it actually changed and allowing for a lot of flexibility when it came to setting up the storage target. And overall, the biggest thing, which we see every customer say, is it completely simplifies their business continuity and their disaster recovery process across the board. With that, we'll hop into a little bit of what the architecture looks like. Here we have a simple overview of Zerto, and it's certainly simple because we just have two sites listed here. Zerto can actually support multiple sites being paired with each other. So the first piece we have is the Zerto Virtual Manager. This is just a lightweight Windows server. It plugs right into your vCenter server, just a couple steps to walk through the wizard to get that deployed. And that Zerto Virtual Manager pushes out something called a Zerto Virtual Replication Appliance. There's basically one of these per ESX host that has virtual machines you're going to protect. And this is what replicates the data. And just to stress, these are not agents. These do not require ongoing maintenance and management. These are appliances that Zerto Virtual Manager manages for you. And from a big benchmark testing perspective, the overhead is very, very tiny. We're talking about 1 to 3 gigs of RAM and 2 to 10 gigs of storage required for deployment. So very, very lightweight appliance. Most customers don't even notice the impact of it on their ESX host in their environment. So first thing that you can see, Zerto eliminates a serious barrier to entry. It's hardware agnostic. So no matter what type of array you have, no matter what type of host you have, it doesn't matter. With Zerto, you're replicating at the hypervisor layer, so the underlying infrastructure is insignificant. This means that you're replicating VMs and VM decays. You're not replicating LUNs. When you're replicating at the LUN level, you decrease a ton of your efficiencies from a storage and network perspective, but Zerto really maximizes your storage and network investments by replicating only what's necessary, which is the virtual machines, which goes back to that example with Woodforest, how they were able to save so much storage and so much bandwidth. Incredibly scalable. With the VRA, it installs seamlessly into your existing configuration. You do not have to disrupt your service, and as you add additional hosts or virtual machines or data stores in the future, all you're really doing is a couple-minute deployment to have another VRA installed on your new host, and with that, you're able to replicate any of the new machines and data that you have within that environment. Continuous block level replication delivers RPO in terms of seconds. So your production workloads can literally have next to no gap in our protection. So RPO in terms of seconds, continuous replication there. There's also a journal for the continuous data protection. It works quite a bit like a TiVo in the environment. It allows you to record everything that happens from a journal perspective from 1 hour up to 5 days worth of data. And this really can help if you have logical corruption, say you have data that goes missing or a malicious attack on your environment. You can rewind back and recover to the exact point in time that makes sense to you. If you have data that gets lost at noon, you can rewind back to 11:59 and 30 seconds or 40 seconds. So it's incredibly efficient when it comes to making sure you failover fast, but also failover to a point in time where you have minimal data loss as part of that process. And last, we have compression and throttling to make sure we're not dominating the network. And this can be very effective to reduce the amount of bandwidth needed between the sites to make replication possible. So the way all this works is Zerto leverages something called a virtual protection group. And what this virtual protection group does is it allows you to add machines, either one or more, into consistency groups. So a good example of this is perhaps SharePoint, Exchange, ERP, CRM, where maybe you have a database backend, you have a web server, you have an application server, and you need to make sure that when you bring those online, they're all in lockstep with each other and consistent across the board. And that's really what these virtual protection groups do. The great thing about them, though, is no matter where your machines are and no matter where the storage locations of those machines are, it doesn't matter to Zerto. So you don't have to move all your VMDKs into a specific data store. You don't have to move all your machines onto a specific host. You can leave your existing machines and applications where they're at in your environment and create protection groups for them right there. And because we don't care where your machines or data is at within the environment, we fully support some of the nice features that VMware has built in, like vMotion, storage vMotion, and of course, high availability built into the environment. All of this goes to a journal, as we mentioned before, which allows you to have those consistency groups with the hundreds, if not thousands of point in times to be able to fail over to or test to as well. So we talked a lot about replicating the data, getting it over to the target site, but we need to make sure it's usable. So Zerto has a ton of automation when it comes to speeding up the recovery time so that end users get access to their applications as fast as possible. When you need a failover, there's just an arrow to hit at the bottom, and I'll show you a live failover here in just a minute. And Zerto begins building the VMs of the target site. You can configure boot order, you can re-IP machines, you can put them on different networks, all as part of this virtual protection group, so that this process takes minutes and the application's up and running. And of course, the most important thing, end users are able to resume their work. Zerto has a really powerful disaster recovery testing feature. It's completely non-disruptive. It can be executed at any time. And while the test is occurring, replication still happens. So if in the event that a disaster occurs, even while you're testing, you can still stop the test and do a live failover. And this testing really builds a lot of confidence to your end users. And in fact, you could generate reports, which I'll show you as part of this demo today, that you could give to management or to an auditing team that really show that Zerto's working well for you and gives you that confidence when it comes time to fail over. And last but certainly not least, there's actually built-in offsite cloning capabilities, which end users can leverage to create copies of their production applications for test and development. So a good example of this is if you're going to be updating one of your applications and you need to verify it in a production-like environment, you could choose one of the points of your journal at the secondary site, clone off a copy of that application, do your upgrade and test in place at Site B, all while not affecting production in any way at the original site, and validate that you're successfully able to do that update before doing it in your production environment. So a very nice, powerful tool there with that offsite cloning capability. So to summarize before we go into our demonstration, Zerto is completely virtual aware. Which, as we'll show you in the demonstration, means that you can integrate it into a number of workflows as far as the boot order goes, as far as which networks you put the machines on, and it being virtualized and software only, upgrades, scalability, all these components take a matter of minutes to install, to put in place, and to be able to very easily protect additional machines along the way. Tier 1 enterprise class, as we mentioned, this really means that you can put Zerto into your environment and be able to protect machines with seconds on your RPOs and minutes in your RTOs, all without impacting their production in your primary environment, and all without maintenance windows or other things like that to have Zerto put in place and continue to run. And last but not least, as we just talked about, all of this can be automated, where with a matter of a couple clicks, you could fail over, have Zerto do all of the various things as far as re-IPing, bringing machines online in the correct order, so that you can really achieve recovery points in terms of minutes when it comes time to fail over between the sites. So with that being said, we'll go ahead and walk through a brief demonstration today. There's just a couple components I'll point out to you. Zerto absolutely works in a standalone web interface. It also integrates directly into your vSphere client. It really comes down to preference. For our demo today, I'm going to run it out of our vSphere client just so I can show you some of the machines in the environment as well as how Zerto interacts with those machines. Okay? So we talked a little bit about the architecture and how simple it is to put Zerto in place. All I've really done prior to our demonstration today is deployed my Zerto Virtual Manager server. This is that lightweight Windows server that links to my vCenter server. Once that's in place, I have my Zerto tab, and I can do all of the rest of the management either through the web interface or through the Zerto tab. Okay? From there, the last step of setup is really to go to the Setup tab. You'll have a list of all the hosts that vCenter can see in your environment. And with a couple clicks, you can highlight those hosts, choose an action on them, and choose to install, upgrade, or uninstall depending on the action required. In this case, I have my latest VRA code installed, and I'm all ready to do replications. So with that, we'll hop into our Summary tab and just take a quick look. Right now in my lab, I have bidirectional replication going on. When you pair sites to each other, you have the ability to push data from side A to side B to side A, B to C. There's really a lot of flexibility when it comes to how you leverage Zerto to protect your machines. In this case, I'm replicating some from Dallas to Boston and some from Boston to Dallas. And you can see at a glance here which SLAs I'm meeting and that everything is working well. Okay. We mentioned before that Zerto leverages something called virtual protection groups to protect machines within the environment. So I'll show you a quick example of these. Really, it takes just a couple minutes to add machines to a virtual protection group. And I'll walk you through just a couple of the components that you can configure on Zerto to make sure that those protection groups meet your objectives. Every time you create a protection group, it's completely independent from other protection groups. So if you have a Tier 1 application, you can set more aggressive goals when it comes to your journal history, your testing frequency, or even the data stores you use for replication and recovery, compared to maybe a Tier 2 or Tier 3 application. So there's a lot of granularity and a lot of flexibility there. Again, without the requirement to rearrange your machines in the environment, Zerto can simply see them through the vCenter interface. So just a couple components to talk about. We mentioned before, Zerto can absolutely support keeping a journal history from 1 hour up to 5 days within your environment. This gives you the flexibility to have up-to-the-minute protection, as well as be able to go back several days in the past to find a recovery point that works well for your failback and recovery purposes. We do have the ability to do quality of service, so if you have multiple VPGs and you have any sort of limitations when it comes to your WAN throughput, Zerto can actually prioritize your VPGs based on the preference that you set here to ensure your Tier 1 applications get the utmost amount of throughput and bandwidth. Zerto, as we mentioned before, has RPO in terms of seconds. An average customer with us is going to see typically checkpoints in the 5 to 15 second RPO perspective, but you can set alerts based on your VPG. So if you do have a network outage at your site, or you have congestion or other things like that, Zerto can notify you if there's any sort of overage on that RPO alert for your SLA there. And the last but not least, we definitely encourage, as we mentioned, testing on a frequent basis. One, for your confidence level, and two, it's completely non-intrusive, so you can test anytime, any production hour, and be able to generate a report, as I'll do for you here in just a minute, with a couple clicks. Zerto has the ability to remind you, so you can come in here and you can set a preference saying, hey, if I don't test every 3 months, give me a quick reminder notification that it would be a good time for me to do that test. Okay? From there, the rest of the configuration is very simple. I simply select the target site that I want to replicate to. As I mentioned, Zerto absolutely supports the peering of multiple sites with each other. And from there, I just choose the host or cluster that I want to have my machines restored to, and the data store that I would like to use for storage for my journal, as well as the recovery disk. And then last but not least, under the settings, this is a very powerful tool, but Zerto allows you to specify a unique network for failover and a unique network for testing. And this is one way that Zerto can absolutely be non-intrusive when you're doing tests, as you could create a unique network at the recovery site just using standard switch ports or distributed switches or whatever. It's, as we mentioned, Zerto's virtual aware. So you could create a network in Site B, and within a minute or so, you'll have it in the drop-down list here to choose from. That way, when you're doing your testing, you could bring your machines online, have connectivity to them, but being able to put them on a network where they're not going to conflict with your production machines is key to make sure that that test is a very smooth process and that you can do it as often as you like. And finally, as far as the VPG goes, the really last thing to do is to be able to add machines to it. Adding a machine is very simple. It's a one-click operation. You select the machine you want to add and click OK. And from there are a few other nice advanced categories of things you could do. So if you have a VApp or VPG that you're creating where you need a machine to be on a specific data store, maybe your database server needs to be on a different LUN at the target site, you can come in here and choose your data store settings. If you've already got data at the secondary site, you could speed your install process even further by preceding the data and having Zerto immediately begin replicating between those two rather than doing an initial sync of data. And as well, last but not least here, on the network side, if you have multiple NICs on a machine, maybe you have a DMZ internal approach or you just have multi-home machines, you could come in and on a per NIC basis tell Zerto what to do when you're doing an actual failover event versus a test event, including the ability to re-IP machines, to change their MAC addresses, and other components like that that really make recovery as automated as possible, since Zerto is doing those actions for you rather than having to manually do them after the fact. All right. So as we mentioned before, I walked through a few detailed components there, but truly a VPG can be set up in a matter of minutes, and then you can have your machines protecting between the sites quite seamlessly. So a couple things I'll show you real fast, just to sort of show you the ease of using Zerto, is I'll show you a failover test and how it is completely non-service impacting, and then I'll show you an actual failover event and how you can automate recovery and failback after that failover event. So you'll notice no matter where I'm at in the Zerto interface, I always have these move, failover, and restore options down at the bottom of here. This really makes walking somebody through the failover process quite simple, especially from a runbook perspective. I've got it set to test, and I'm going to click failover. Zerto will show me any of the VPGs I have, no matter where they're at from a site perspective, that are able to be tested. I'll just choose my web demo right now, and I'll click next. From a testing perspective, I could choose any of the checkpoints I have. So if I come in here, I could choose some of the testing that I've done in the past few days. If I have VSS snapshots integrated into this, I could choose a VSS point in time. Or if I'm looking for a specific window of time to recover from, I could come to the selection window and just to use the use case we were talking about before, perhaps I have a machine that had an issue that occurred at noon, and I want to make sure that I get as close to noon as possible without losing any data, but prior to the event occurring. So maybe I'll go back to 11:59 and 42 seconds and choose as my checkpoint. You can see it's updated here, and I'll go ahead and click next, and then failover. And we're doing a test event, so I'm in the primary environment right now, and you'll see nothing's happening to my production machines. Everything's still alive. But if I go over to my secondary environment, it's immediately brought these machines into inventory. And it's walking through a number of steps. Again, Zerto automates all this, which is far faster than I can click through it. But it's putting the machines onto my test network. It's re-IPing them. It's bringing them online in the correct boot order. I told it that I wanted the database server to have about a 30-second window before the web server came up. And it's just walking through all those tasks for me. And really, as you'll see as part of this demonstration, a test really only takes about a minute or two to execute before the machines are online in the secondary environment on that network you specified, and able for you as an end user to either open up the console to interact with it, or maybe RDP or have a workstation on that test network for you to be able to do some good validation within the environment there. And again, just to show you back in the production environment, absolutely nothing's occurring. None of my machines are affected. If I open up a console view, it's a Linux-based server, so it's not a lot visually going on in here. But the machine's completely unaffected from a production perspective, still sitting at my login prompt. And that's really it. That's how fast you could do a test scenario. You can see both of these machines are live. They're able to be accessed, and nothing was impacted from a production perspective. At this point, what I could do is, as I mentioned, log in, check it out, validate that I'm happy with this test, and then when I'm ready, I could simply click on the stop button here. And as an end user, I could choose whether or not I thought it was successful. I could create some notes, and I'll show you here in just a minute where these come into play, and I'll click stop. The cleanup process takes maybe 30, 45 seconds. It's going to shut down these machines in the test environment and simply remove them from inventory. Replication continued occurring the entire time. You can see here under the summary tab, I never stopped replicating. Everything was good. And my production environment going back to hit, again, nothing's been affected. Everything's still online. But what I have at this point is I've performed a test. I brought a machine online in the secondary environment. I found out that it was working well, and I stopped the test. From here, I actually, there's a number of reports, and I won't walk you through them all today, but there's a lot of very nice info here about bandwidth savings, usage, compression, other things like that. But I'll go to one of my favorite reports. It's something called a recovery report, and I'll go ahead and generate one. Let me grab this for you. It's going to pop up in a different window for me. I'll go ahead and pull this over. And here's what a recovery report looks like. So what it does for me is it quickly shows me when I generated the report, who was initiated by, and in my lab environment, I simply just use a user named root. But if you have different users, it'll show that. It'll show whether or not me as an end user validated and said, hey, this looks good, this was passed. It also showed me what my overall RTO was. In this case, these 2 minutes, it took about 1 minute and 15 seconds to bring online. You can see that I thought this was successful and I validated it. On page 2, it shows you each of the steps the Zerto did as part of that failover test. So you can see here, it did a number of things for me. I brought the machines online and put them on the correct network. It powered them on in the correct boot order for me, and each of these steps was seen as successful and how long it took Zerto to accomplish that, which overall was my RTO to have those machines online. So really, really easy to bring up like that. And to be able to have a report in an auditor's hand or a manager's hand in a matter of a couple minutes to show, hey, we're definitely getting our money's worth, Zerto's working correctly, and we have confidence that it's going to work in a failover scenario. And with that being said, I'll show you how an actual failover works. There's just a couple differences, but overall it works very similarly. So what I'll do is I'll go ahead and switch this over to live failover. Now move and live failover are very similar to each other, both of them. The purpose of either of them is to have your production machines be on the secondary site and to be able to enable replication back to the original environment all in an automated fashion. So let me show you how that works. I'll go ahead and click on live and I'll click on failover. And you can see I have both of these available. I'll go ahead and do a different server just to show you Boston to Dallas. At this point. I'll click next, and you'll see there's a couple new components here. I still have the ability to choose my checkpoint, but I also have the ability to set up reverse protection, and I also have something called a commit policy. And this commit policy is a very powerful tool. This basically allows me to power on the machine at my recovery site, to log into that machine and validate whether or not I picked the right checkpoint and whether or not I want to commit to failing over using that point-in-time recovery. So I'll very quickly set maybe a 30-minute timer here so I can show you what that looks like. And I'll choose to shut down my machine as part of this failover process. If you don't have connectivity between the sites, you can choose some other options there. And I'll click next. You'll notice this window is a little different. It's just letting me know this can't be undone. You're actually failing over. And I'll go ahead and click failover and show you what that looks like. So let me get my recovery report out of the way. And let me pull up my Dallas environment. And you'll notice the behavior is going to be just a little bit different here. So what I'm doing is I'm bringing my Windows server online in Dallas. This machine will be powering on here in just a minute, and in the source site, because I'm doing a real failover and I told it to shut down the machine, you can see that the Windows server is now shut down, again, all automated. In my production environment, it's putting it on the correct network. Any failover scenario, you could choose to use a different network than in the test scenario. So it's putting that on the correct network for me. And then last but not least, it'll be powering it on here in just a moment. And when it does, I'll have this new option, which will be, and you'll see an alert here pop up in just a minute, that'll ask me, hey, you asked to have a window of time. In this case, I put 30 minutes, but it could be any amount of time, where you wanted to validate that you brought on the correct machine and that you're happy with what you have before you commit to using this permanently in the environment. So here's a good example of that. I now have the machine fully failed over. It's powering on. In fact, if I open up a console view, you'll see a Windows prompt here as it boots up here in a minute. Give that just a second to populate. There you are. So you can see the machine's failed over. It's powering on in the new site. And I now have a new task down here at the bottom that says, hey, you asked us to wait for user input. So before we commit this to being a machine live in this environment and for production purposes, you can open up the console, you can look at it, you can verify it, and in this case, I'll go ahead and click commit. It gives me one more chance to change anything from a reverse protection perspective. In this case, I'm happy with what I've got, and I'll click commit. And what this does is basically this Windows server is now going to be running just as a normal VM at my secondary environment. It's no longer running off of anything on the journal. And as soon as it's done committing that VM, it's going to configure reverse protection, where as soon as it has connectivity back to the primary site, it'll begin doing a delta sweep between the two sites to see what's changed, update that, and then start doing a continuous protection replication back to the original site as well, which gives me, again, without any added manual steps, the ability to fail back later on with that same RPO in terms of seconds and failover in terms of minutes back to my production site. So you're not held hostage. Zerto is a great tool for failing over, but equally as important, really powerful tool for doing automated failback after that fact. With that being said, we'll take a quick pause and we'll take a look at some of the questions that we have here in chat and see if I can't answer any of those for you. So a couple of the questions we have is asking, how is Zerto licensed? And that's a great question. There's really two answers to that, but both of them are completely licensed on a per machine basis. And it's not locked down to a specific machine. It's just locked down to the total number of machines you want to protect. So for example, if you bought 50 machines worth of licensing and you later on replaced some of the machines or added more machines to the environment, you have the flexibility to use those keys as you see fit. But it's completely licensed on a per machine basis, whether it's between your sites or to a cloud provider as well, as Zerto is cloud capable, to VMware-based clouds as well as vCloud-based clouds. We have a couple other questions here. Is Zerto suitable for bulk B2V migrations instead of VR? And the answer to that is absolutely yes. As you can see down here